All right, so 8.3, definite integrals in applied context. So we have, over the last couple days, we have looked at applied context. But our applied context has been specifically geared towards our straight line motion. In this one, our applied context is going to be more generalized. So this is, we are going to take some of the stuff that we're going to be doing is going to be very similar with some of the stuff that we have done previously, right? So we have our definite integral and net change. Have we talked about net change the last couple days? Yes, that was our displacement, right? And so the displacement, that word primarily focuses on straight line motion, but the more general term is net change. When we're talking about the change or the difference between our starting amount and the ending amount, that is our net change. That is the definite integral. So the definite integral represents the difference or change, as I said, between the starting amount and ending amount. It represents how much has changed during that time interval. So you might be asked, interpret this integral in the context of the problem. We have seen that actually back in Unit 6. We saw it a little bit. We've seen it again here, where we can go ahead and interpret by saying, hey, that integral, if they ask us to do an integral, represents that net change, or how much has changed, or how much has accumulated, there's that word as well, over that time interval. Okay? So you can also think about it as how much has accumulated or gathered together, right? How much has been accumulated. So this is our just normal integral, the integral from a to b of f prime of f of x dx, or f prime of x dx. F of b minus f of h, just our normal FTC. Again, giving us that net change of the function's antiderivative, the accumulation of that function's antiderivative. If you want to find a new value, you can rearrange FTC in this way. Doesn't that look familiar, guys? Isn't that what we are doing with that new position type situation? It's the same thing. It's just in our straight line motion, we're specifically looking at a new position. In this one, it could be a new value. Any new value, any value that is going to be happening later on. To be able to do this, they will have to give us an initial value, some initial starting point. Once they have done that, though, we can find any new value if we know our antiderivative, or if we know the derivative, the f prime. All right, so let's go ahead and look at problem number 1. This is Calc Aloud. So have those available and ready to go. So it is known, a function is known to be increasing at a rate modeled by f prime of x equals 3x plus sine x. It is also known that f of 4 equals 15. There's our starting point. They want us to find f of 7 and f of 2. It's 2 different points. So we are going to be using our FTC. Whenever they give us the derivative, they give us a starting point, and they want us to find a new point. We are going to use FTC, which is our integral from a to b, f prime dx equals f of b minus f of a. So let's go ahead and do that for our first one. All right, so f of 7, what does that equal? So what would be our setup for FTC? Let's do it the FTC way. I want us to be careful with that, okay? So the integral from where? 4 to 7, because that's the one that we know, f of 4 equals 15. 4 to 7, so 4 to 7, of our function 3x plus sine x dx equals, what does that equal, guys? F of 7 minus f of 4. Which one do we know? F of 4. What are we going to use our calculator for? The integral, right? Now, we could rewrite this and say then, well, f of 7 equals, we can add that over, and that'd be f of 4 plus our integral 4 to 7 of 3x plus sine x dx. And you can go ahead and throw that all into your calculator, f of 4 being 15, and then do your integrals. Go ahead and calculate it with your calculator. What is f of 7? So what is f of 7? What did you guys get? All right, I agree. There we go. All right, let's set up the next one. We have to be very careful with this one, though. So what are we wanting to find? F of, what do we know? We can actually use either one. I would still use f of 4 because that's a nice whole number, not a decimal. That's what I would recommend. All right, so what is our integral? The integral from what? 2 to 4 of 3x plus sine x dx, and what does that equal? F of 4 minus f of 2. Which one are we calculating, though? So it is different than the last one. You have to be careful. That's why I recommend you write out your FTC. Okay? So you're solving for f of 2. There's a couple different ways of doing that. What would we do first? All right, so we can subtract what? So you could subtract the, so there's two options. You can subtract f of 4, or you can subtract the integral. Okay, which way do we want to do it? Doesn't matter to me. Who wants to do subtract f of 4? Who wants to subtract the integral? It's like about 50-50. So do your way, whichever way you want to. Doesn't matter to me. Okay? Eventually, in the end, I'll write what you should get in a minute. But do your way. Solve for f of 2. What would f of 2 be equal to? Not the number yet, but just what would be written out. What would that look like? F of 2 equals what with the f of 4 and the integral? What would that setup be? All right, so what you should have is something along the lines of f of 4. Is it plus or minus? Minus our integral from 2 to 4 of 3x plus sine x. So that is where we have to be careful in these problems. You have to know where is things going. Which one are you solving for? All right. Go ahead and plug that into your calculator, and what do you get for f of 2? All right, what are you getting? Negative 3.237. Do we all agree with that number? Hopefully, because that is correct. All right. Any questions on finding that new position or new value? So again, it's the same as our new position type situation. We set up our FTC. We solve for the one that we want to find out. All right, problem number 2. Calcul out again. A tank of water is leaking at a rate modeled by V prime equals to negative 25 pi over the square root of t, where V is measured in gallons and T is measured in days since the leak started. No water is being added to the tank. The tank is just leaking. The tank held 2,000 gallons when time was at 2. That is 2 days. So after 2 days, it was holding that. How much water is in the tank 4 days after the leak started? So 2 days after the leak started, there was 24,000 gallons. How much water is in the tank 4 days after? So 2 more days later. Okay? So, this one is not spelling it out for us. We have to take the information from the context. We have our derivative, though, v prime. This is our initial amount. So how would I write that? V of 2 equals 24,000. That is the amount in the tank after 2 days. Okay? What about this one? 4 days after. How would I write that? That's our question mark. So how would I set it up? Two to four of and that equals not f, v of 4 minus v of 2. Is it the same thing that we're just doing? Yes, it is. Use your calculator, figure out, solve, and get your answer, please. What is v of 4? All right, ladies and gentlemen, how much water is in the tank after 4 days? 9, 8 what? 5? Does it round up to 5? All right, sounds great. And then what's our unit? Gallons. All right, there we go. Okay. Let's go ahead and turn the page. Problem number 3. I want you guys to go ahead and read it. See if you can set up your problem. All right, ladies and gentlemen, I want to start looking at this one with you guys. Some good work happening out there. Now be very careful in the way you're labeling things. Okay, so a printer is publishing multiple copies of a specific document. While printing, the ink is being used at a rate of, so R of t is our rate. So R of t you can think of as your F prime. That is your rate already. All right, if the printer started with 5 ounces of ink, so I heard somebody say like R of 0, that would actually be F of 0 if we're letting R be F prime. Please don't label it as R of 0, okay? Because that would be wrong. I know it seems small, but it is still those, we want to be very precise in those little things. R of 0 equals 5. And then we want to know 3 minutes after printing, so that's kind of like our F of 3. All right, so then what would be our setup, guys? Zero to 3 of equals, so you used P, that's fine, P of 3, so that's P, the printer. I used F, so I'm going to keep with my F of 3 minus F of 0. All right. Well, calculate F of 3, please. All right, I'm hearing some answers out there, so what are we getting for F of 3 with this setup? Ounces. Okay, does everybody get that with that setup? Okay, before we mark it as correct and we move on, read the problem again. Does this answer make sense? In context, does that answer make sense? Why not? The amount of ink increased. Can that happen when you're using the ink? Shouldn't the ink decrease? not increase. So what do we have to adjust because of our context? We have to subtract it. So we have to be very, very careful with these contextual problems. This does not make sense. Don't cross it out. Just write what I do. It doesn't make sense in context. And hopefully you left yourself some room to correct it. All right? So, when we do the integral for this problem, the integral from 0 to 3 of 0.2, 1 plus cosine of t dt, which looks like it was 0.628, that number is actually how much ink was used. So what would we have to do to correct this problem? To get the actual f of 3, what would we do? We do the same thing, but like I heard over there, what do? 5 minus that integral, which I'm just going to write as the decimal 0.628. So, if you put it in your calculator as this, just go back up, hit enter, and change the plus to minus. What is our actual answer that makes sense with context? All right, so what is our actual amount of ink? Should be 4 point something. 4 point what? 372. All right, 4.372 ounces. Does that make sense in context? Yes, it does. Because ink was decreasing. That is a decreasing rate, so we had to make it decrease. So yes, you have to pay attention to the context when you do your work. And the work was great. That's what we normally do. But then you have to pause and just double check, does the answer make sense in context? Because if it doesn't, then you might have to adjust something.